So you're fine doing it, huh? So what is dynamic programming? To understand that, let's look at the code for Fibonacci series. You see here that the code is bad, very bad. Time complexity being exponential in this case. So how can you improve this? Just pause this video and write how you can improve it in the comment section. Well, let's look at this way of writing in the code for Fibonacci series. Here we are looking at, have we previously encountered this problem before? If we had, then return that, else calculate it and store it. This may not look much, but this just takes the time complexity from exponential to n. Since there ends a problem in the total, and with memorization, you are not wasting time finding solution for the subproblems that you have already solved once. This was memoized TP algorithm. Let's look at text justification. Text justification is about splitting the text in the lines. So one approach that we can use to solve this problem is to fit as many words put in the first line and repeat. But this is a bad approach as it can make very bad lines. So let's look at another approach. Here we define criteria for good and bad lines by calculating difference between page width and color length. And cubing it, so if the difference is small, cubing it will make it smaller, and the difference is big, cubing it will make it bigger based on that. And we will define how the line split. This is defined as badness. Here our subproblem is to fit n minus words in the line and completely ignoring the I words, how those were fitted. And so our subproblem is going to be how we're going to pack the words that are left. Also here we have to guess where to start the second line. And using recurrence, we can call these subproblems down to n, then n minus 1 and minus 2, and see how the good words based on the badness. And this is guessing at first, and then based on the badness, we're going to choose one from those guesses, and that takes the time complexity from to big O of n square or theta n square. Since the subproblem is there is the n subproblem and guessing takes n time, the time complexity is theta n square in this case. Okay, this is a fun one, the blackjack. So the rules are, this being a two-person game where you pick two cards first without knowing what they are and see their sum. If it's bigger than you choose, if it's bigger and then you choose if you want to again pick two cards. If it's bigger than 17, you stand, else you choose two more cards and you see their sum. If it's greater than 21, you lose. If you and the dealer, both their sums are less than 21, you compare your cards and see whose points are more. If yours are, you win $1, and if you lose, you owe the dealer $1. Else, it's a tie, and none of you gain anything from this. So, what dynamic programming has to do with this? So, you are given ability to see the whole deck in front of you, and you have to maximize your gains. That means you have to maximize your profit in the game. So far, we have seen the DP involves subproblems including recursion and guessing. In this case, what other subproblems you think we can divide and that we can call during recursion? Well, that is how many cards are left after the first game and so on. And what is playing for these remaining cards? So about guessing, how many times player draws another card. So we will try to maximize our profit, and here we're gonna see that we can recursively call our function and adding the subproblems. Here we can use to improve our future cards as well, and here time per subproblem is big O of n squared, and that's bring the total time up to theta n cube. So the code says if you have less than 4 cards, then the game is not possible. If your sum, the player sum is greater than 21, player loses, and then we recursively call for the next game, then the next game, and in the game we see the player cards and the cards of the dealer. So the subproblem is n square, and the calling is and the guessing is n, and that's how it's n cube. And Here you can see that the player first check his card, and if it's greater than 21, we add a lose value and cursively calculate the player next game, and then the next. And I think that we will first see the last game result will be added. Also, in the dealer scenario, we do the same thing. If greater than 21, we win, or else we'll compare the cards. Okay, so what is DB now? I ask you this question now. So what is DB? Write your answers in the comment section. DB refers to simplifying a complicated problem by breaking it down into simpler problems in a recursive manner. So, if you like the series Test Justification and Blackjack, we were simplifying our problems by breaking them into sub-problems in a recursive manner. Also, fun fact, dynamic programming was developed by Richard Bellman, and Bellman invented the term DP to hide the fact that he was doing mathematical research at R&D under a Secretary of Defense who had a pathological fear and hit the word research. Yeah, it's weird. Okay, so if you like this video, subscribe, and I hope I see you in my next video. Peace.